What's up, ladies and gentlemen and prospective employees? If you're on this video, then either you've seen it on my YouTube channel, this is potentially my first YouTube video, or you've clicked the link in my resume. So basically, this is a side project I did in the second semester of my junior year, where I analyzed the iMessage data in one of my group chats, because we were all curious in this group chat of about 20 odd people, about who gets the most laughs, who's the funniest in the group chat, who gives out the most laughs, who likes the most, dislikes the most. If you're familiar with iMessage, then you know what I'm talking about. It's the reactions that you can give to certain texts. So this video is an explanation slash tutorial of what I did. And I hope you guys enjoy and take some inspiration from this. So without further ado, let's get started. So the first thing is I backed up my iPhone onto my Mac, and it creates this backup file here. And in this backup file, you have a lot of different folders that are named randomly, but in this 3D folder, this file right here is actually a database file. And this file contains all the messages that are contained within your iPhone. So what I did is I took this file, I dragged and dropped it into documents, and I just named it, well, these are the same file, I just wanted to test something out, but you have to rename it as a .db file. And once I do that, then I can open it in this application called Archetype, which is very useful for SQL work. And so once you open this file, you get all these tables, and I will show you exactly how to use this. So the main table that we have is this message table. This message table contains all of the texts, all of like specific identifiers in the rows, and just contains a bunch of information. So this is the query I used for part one. So this is a two-step process that I used. The first step is to use the SQL with a Mac to actually get a table of what I am looking for, which I'm about to explain here. And then phase two of it is taking this table and just for ease of use, putting it through a Python data frame and using that to actually come up with the analysis. So this is part one. So this is the table that I came up with, and this is the table that I'll actually be analyzing, or the table that I've generated through the query. So I'll go ahead and explain it. This is all SQL, and I'll explain exactly what it does. So the first thing I had to do was get the reaction and what it was reacted to into the same table. So let me just go through. So this associated message type, so the select keyword in SQL just means that these are the columns that you'll actually show from your table. So what I have selected, so there's three here. I have an associated message type from the message table, and this gives me this gives me the type of message that it is. So for example, if your associated message type is 2000, then that means that it is a laugh reaction, or it is each of these from 2000 to 2005. Each of these reactions is a different type of unique reaction. So if I actually made a table, okay, yeah, so these are the actual specific reactions that we have. but for just sake of simplicity, I chose to just keep them like this, as opposed to actually joining it with that table and then using these values like loved, like, disliked. But anyway, okay, so that's the first thing I selected, and then the next two things are from the name table that I created. And this name table I created specifically for this group chat because I knew which group chat that it was that I was going to analyze for my friends, right? There was the one main big group chat that I wanted to do this analysis for. So I have n name as name of reactor, and then n2 name as name of reactee. So basically what that means is, in this column, I have the name of the person who reacted to a chat and the name of the person who got reacted to. And that was very important, obviously, because I wanted to know not only who laughed the most, but also who gets the most laughs. So, and then the from keyword is telling us where these selects are coming from. So from message, and then I joined several things to it. So let's just go through that. So the first thing is I join the handle table H on to the message table using the handle row ID and the m.handle ID. So basically this handle table gives us the number of everyone I have in my database, and it also gives me a unique row ID. So using that and joining it with my message ID, handle ID, I believe it is. It's somewhere here. Oh, handle ID right here. So using this, I can tell who sent what message, joining it with this handle ID. So next, I have joined message P on m.associated message UID, and then this. So let's just go through this. So I have another message table, which I join together with my original message table on this, where this is true. So basically what this is for a reaction. Let's see if I can find a reaction here. For example, so this is the text, it's liked something, right? And the GUID of this, or excuse me, the GUID of the associated, let me see if I can find it. Oh, right here. So this is the, so this is the associated message GUID. And what this means is this tells us which message it was that this is a reaction to. So this is just a syntax for it. I'm not sure exactly what this beginning part of it means, this p:0/, but with this we can get the actual message that it was reacted to. So for example, so this is 954CA something something something. So if we go back to our GUIDs, we see that 954CA72 is right here with the message less train, and then here obviously we can see that this message is liked less train. So that is the reason for that. And so what this does is it appends this little p, the beginning of it, the p:0/ with the p.GUID, and if those are equal, then it joins them together. And what that does is it associates the messages to the reactions. Excuse me, it associates the reactions to the actual message that it was reacted to. So next, excuse me, so I have another handle H2 table, and I join that with the other message table that I have, just so that I can tell like where that reaction message text is coming from. Next thing I do is I join the name table n on n.number equals h.id. And so basically what this is, so for example, in the handle table, h.id gives you the actual phone number, and the name table is the table I created, and I manually created it where it had all my friends' numbers and their associated names. So that's what I did here, and I did that both for both of the handle tables, H and H2. And then finally we have another join with chat message join, where you join the chat message, the message ID with the m.row ID. And so if we look at the chat message join table, it just has the chat ID and the message ID. So for example, so the message ID in this table, where is it? The message ID shows us actually which message it is, and the chat ID tells us which chat that message is associated to. So if we go back to the message table, there is obviously this ID right here, the row ID. And so each message has a distinct row ID. So when we join those two things together, we can access which chat ID each message came from. And so finally what we do is this where keyword, which helps us filter out all these messages. And so we have the cmj.chat ID equals 903, and this is the chat ID that I just got manually from looking at the message of this specific chat that I wanted to do. And lastly, I ordered it by decreasing date, and so the result is this table here. I have the associated message, which tells me what kind of reaction it is. I have the name of the reactor and the name of the reactee. And as you can see, this is, I'm in a fairly active group chat, and I had 1 year's worth of data. So we have 12,048 rows of this data of just reactions and who reacted and what the reaction was. And obviously I just showed you the culmination of everything I found out, but as you can see, I had a good amount of testing that I had to do for this. I have many queries. Unfortunately, I didn't I didn't make this video right after I did all this. It's about a month later, and so I lost a lot of the tabs that were there. But that's a brief description of phase 1 of this project. All right, and this is phase 2 of my iMessage reaction insight little side project. And so the second part is being done in Python in Jupyter Notebooks, just because that's what I'm comfortable with. And we're using the pandas library because it's very good for data analysis. So let me begin with the explanation. So the first things first is we read in the reactions.csv file that I had created before, and this table should look familiar. Associated message type, name of reactor, name of reactee. So we just have this table. I've just printed it out here. Okay, so here now we get into the nitty-gritty a little bit. So the first thing I do is I create a dictionary, and for each person in this group chat, I have 6 tallies that all start at 0, and each of these 6 tallies keeps track of which reaction each person got from all of the reactions that we have in this data frame. So for example, so we loop through every reaction in the table, and then we look at each reaction type and we append it to the appropriate person. So for example, if the reaction is 2000, go through the names of each of the participants, and then if the name of the participant, if the name of the reactee matches up, then we simply append 1 to whichever index it should be. So for example, for 2000 it's 0, 2001 1, 2, 3, 4, all the way down. And this is obviously pretty inefficient, but just for sake of time I didn't really worry about it too much because it doesn't really take long to run at all. So once we do all that, then we create a data frame from the data, and we title our indices love, like, dislike, laugh, emphasize, question for all the 6 types of reactions that we have. And then we can sort it for each one. In this situation, I just chose love, and I just printed it out to make sure what I got. But here is the actual data frame that I've created now, and this one is specifically for gets reaction. So that means these are the people who they got the most love reactions on their messages. So here, for example, we have Nick. He gets the most love I guess on his messages, and so just like that, and we can order it in any way we want, but this is the data table for who is getting these reactions. And I applied the same method again, but instead I do it with who is giving these reactions now. So you'll see that I check the first column instead of the second column, because of how I structured the data, name of reactor versus name of reactee. So this, now I do the exact same thing, and this data table gives me who reacts the most. So this data table shows who does the most reacting and what reactions they actually do, and this is ordered by love, but I could order them by anyone. And so I do that here. So you can just when I do this, you just type in which one you want it to sort by, and you will get that data table sorted for you. So in this one, I wanted to see how these numbers compare to the total number of texts that were sent in this group chat. So I had another another CSV file that I exported from the SQL on the Mac, which I didn't show, but basically it was essentially just had the name of the person and the text that they sent. And so all I do is I just go through this CSV file, and I have another dictionary. This one's a little simpler, just one column for each person just to say how many texts they sent. So I go through this table and I just append each time someone sends a message. And then what I do is I create a data frame for that, which you can see here. And I actually append this to our other data tables. So for example, here we have our gets reaction, and here we have the total number of texts that each person has sent. And so this is just, I put this into a CSV file, and I do the same thing for table. So what I wanted to do with that is actually get the ratios of their message to, or excuse me, their reaction to their total number of text ratio. So that's what I do. I basically just go through the data frame and I divide each number by the total number of text, and that gives you a little bit of a ratio, and you can order this ratio for however you like. So for example, you would see that Manish nearly has double the text of everyone else, so his ratios obviously go much further down. And so if we want to sort this, once you run this cell, you can just type in which one you want. For the sake of time, I'm just going to show one that I've already done. And so we can see that these are now sorted by who is questioning the most. And that's that. And then the final thing I did obviously there's a lot of applications of different things you want to see, but this is where I stop basically. Is I made a plot of the distribution of the type of reaction that a person might um, impart, I guess, to another message. So for example, so this is my distribution in this specific chat. These are how the probability essentially of how I might react to a chat. Given that there is a reaction, how might I react to it? So clearly my distribution is I'm laughing mostly, and then some emphasizing, and then everything else is pretty low. So this is the culmination of my project. I hope you enjoyed it, and I hope that it's enough information for you to go out and do it for yourself if you're curious. I know that this project caused a little bit of dissension in my group chat because people were, trying to save their ratios now that I showed that I exposed the data, but